Hello, in this video we're going to select a profit maximizing team quality. A team's ticket price is a function of the quantity of tickets sold and the number of star players on the team. So again, the ticket price is a function of the quantity of tickets sold and the number of star players on the team. The team's costs are going to be a function of the number of tickets sold and the number of star players on the team. Profit is revenue minus cost. So price times quantity is revenue. So here's price multiplied by Q to give us the revenue. And then we're going to just subtract out the firm's cost, the team's cost. And now let's derive the first order conditions. I'm going to take two partial derivatives. Going to take the partial derivative of the profit function with respect to the quantity of tickets. And we're going to get back this result right here. Setting it equal to 0 because we're maximizing. So just moving some things around. This tells us to maximize profits. We want the marginal revenue of tickets to equal the marginal cost of tickets. The left-hand side is the marginal revenue, and the right-hand side represents the marginal cost of tickets. The second partial derivative is a partial derivative of the profit function with respect to S, the number of star players. And we get back this result, once again setting that partial derivative equal to 0. And just moving some things around here. We have the marginal revenue of star players equal the marginal cost of star players. And the partial derivative of the inverse market demand equation, the P equation here, with respect to the number of star players, we do expect that to be positive. As there are more star players on a team, the fans' willingness to pay should increase for tickets, so that should be positive. There could come a point where adding an additional star player generates less added revenue than the added cost, reducing the team's profit. Therefore, maximizing profit is not the same thing as maximizing the team's winning percent. All right, let's do a numerical problem. So here is the team's inverse market demand as a function of the quantity of tickets sold and the number of star players on the team. And here is the firm's cost equation. So again, our first order condition, partial derivative of the profit function with respect to output, we showed the following. So we can just substitute in our results into this equation. So following our first order condition, we're going to put the price in here. We're going to substitute in for P, which is 42 minus 2.5Q plus 10S. And then we're going to take the partial derivative of the price equation with respect to quantity and multiply that by Q. So first, the partial derivative of the price equation with respect to Q is just minus 2.5. And then we're multiplying that by Q. So that's where this minus 2.5Q is coming from. And then taking the partial derivative of the cost equation with respect to Q, we get back this 2. So minus 2 then. And setting that result equal to 0. And just simplifying this, 42 minus 2, minus 2.5Q, minus 2.5Q. So just doing some simplification there, we have this result. Our next first order condition, we showed when we take the partial derivative of the profit function with respect to S, we get back this result. So let's plug in our results now. So the partial derivative of the price equation with respect to S is 10, and that's being multiplied by Q. So that's where this 10Q is coming from. And then taking the partial derivative of the cost equation with respect to S, that's going to be 100. So we're going to subtract out 100 here. So just rewriting our two first order conditions. And now let's take this second equation and solve for Q. Plugging this Q equals 10 into this equation right here. And simplifying. The number of star players equals 1. We have our price equation, inverse market demand. We're going to evaluate that where Q equals 10 and S equals 1. And ticket prices will be $27 each. All right, I will stop here.